Excellent. All right, everybody, welcome wherever you are. Thank you very much for spending your time with us. We have an exciting Executive Insights webinar for you today with our awesome alumni, Milton Walker. So before that, going to go over just a couple things, and then we're going to dive into digital transformation, how AI and robotics enhance human potential. So before that, I just kind of want to give you a little overview of what we do here in the executive business programs. There's different ways you can interact with us through our custom executive certificate programs, our EMBA program, and as well as capstone projects. With our custom certificate programs, we'll cover topics in strategy, innovation, leadership. I have the pleasure of working with many different organizations and helping them level up their teams. Here's my team. Work with some great colleagues here in the Saunders College of Business. And a little bit about our EMBA program, if you would love to go through that. It's a 16-month accelerated cohort-based program. We cover business core with some leadership and, of course, a tech focus on that. Everything is experiential learning through simulations, and we do different trips throughout the experience as well. We have an online and a new hybrid format this year as well. And for our capstones, I'm always looking for companies to participate in our capstone. It's essentially free consulting. So if you're looking to solve a business problem or answer some questions about new markets or revenue streams, our EMBA participants would love to help you out. So Milton Walker, EMBA graduate here, as well as an RIT grad in 1997. Milton's a director of business development for NexCOBOT, which is a NexCom company, and he's focused on growing NexCOBOT's robotics business here in North America. He is an expert in relationship building and helps customers identify and resolve critical business problems, maintaining a deep technical knowledge in many different disciplines. Milt has been in the computer industry for nearly 30 years, recently focused on robotics and automation. Much of that time was spent in Intel, and with various roles focused on helping customers learn and grow their products and technology. He's a trusted advisor and has created many connections across many different sectors. Milt is down in Atlanta, and he serves on a few different boards and local organization, including Decatur Makers, which is a family-friendly maker space, Robo Georgia, an organization that helps grow and cultivate the robotics landscape throughout Georgia and beyond. He is into astrophotography, mountain biking, snowboarding, and sounds like he's a tinkerer too, fixing electronics. Loves to travel, learn new things, make music, as well as listen to and watch and reading sci-fi. So there's the big intro. Super happy to have Milt today. And now I'm going to turn it over to you, Milt.
Thank you so much. Yeah, great. Awesome intro. I very much appreciate it. Are you guys seeing these slides now?
Yes.
So first, very much appreciate the platform and giving me some time and space to be able to talk about, something that I love, robotics, automation, and those topics. So thanks, Jancy, thanks, Noah, RIT team, and most of all, thanks for the folks joining. So let's just jump into it. We'll talk about automation, and we'll talk about several things that, ultimately what I'd like folks to take away from this presentation. So Noah's great intro. I think I'll talk just a little bit about what got me here. So I'll do a little bit of my own path and my own sort of, what brought me to sort of this conclusion and why did I focus on robotics and automation, what got me there. Talk about some definitions in the ecosystem, as well as digging into how this is relative to intelligent automation, how this impacts people, And then at the end, we'll pull it all together with, you know, some takeaways. And then we'll do a quick Q&A. So, but feel free to, if you have any questions, comments, feel free to utilize the chat to add things. Obviously, we've started already with the pet talk, but yes, please feel free to interact. So, quick introduction, and I do this in sort of 7 phases, right? So before this was the before time. What got me into robotics? It really started with several toys, several robotics toys, and the big one that sticks out is Big Trek. And then, you know, one of my relatives recognized the technical person in me, the guy who takes things apart to figure out what they were and how they worked. Bought me this robotics book, and it was by Jazier Reichart. Um, and uh and of course my first programming language, Logo, right? That was a robot turtle, which if you know about robotics, the robot turtle is sort of pervasive in lots of different spaces today. Of course, high school reinforced that, and then my first time at RIT. Um, from there, I did an internship at Intel Corporation, which allowed me to really see the technology in different spaces. I didn't go into robotics after college like I wanted to, but I was still in technology, and that allowed me to get some broad scope on what's happening in the industry. Later, while I was at Intel for quite some time, um, I, uh, I decided I really wanted to learn more about robotics, and it was my second sabbatical, and so 14 years in, um, I decided I was going to go to Japan and buy a robot. And if you look over my right shoulder here, you can see the actual robot that I bought is a small humanoid robot, which building this and learning about the technology just brought me in all kinds of directions and learning this whole ecosystem and really exposed me to all kinds of things that um, you know, normally you wouldn't have access to unless you really had a program that dug into some of the technology. So that robot, that first step was really the critical mass that maybe really directed a lot of things. From there, here in Atlanta, I wanted to show off some of the things that I was doing with robotics, and so I joined Maker Faire, the Maker Faire team here, and then it ended up being director of the organization that runs Maker Faire in Atlanta. Unfortunately, the pandemic came and we had to shut that down. Um, but there's actually a renewed spirit and interest in restarting Maker Faire Atlanta. So I think it'll be in good hands. After the pandemic, I joined SICK Inc., which is a sensor and analytics company. And that really exposed me to several customers that they have that were building industrial level automation and robotics. Um, that really made me want to dig deeper into the business and the strategy around automation and manufacturing. So I applied to go back to RIT to get an EMBA, which is you know, what the team was talking about before. And that gave me a huge, um, a new perspective and really interesting optics on how business is done, why business is done, you know, what about business and around optimization and the different technologies needed and analytics and data and all that stuff that comes together to drive, you know, outputs and outcomes of business. I ended up going back to Intel to focus specifically on growing robotics. I was there for almost 2 years, and then I left, and now I'm at NexCOBOT. So that brings us up to today. And really, what I would take away from this is the journey has been amazing, but it's really been about the journey and all the steps and the learnings along the way. It was never really about a particular place, but it was the journey that led to different things that sort of grew on it upon itself. So it's all about the journey. I know they say it's sort of cliche, but it really is. So let's talk about some definitions. We talk about intelligent automation. What is that? Where does that come from? So let's start sort of at the beginning and talk about industrial revolutions. And you guys probably all know this, but I think it really helps to see what this looks like from a sort of a mapped out perspective. Um, So Industry 1.0 was the steam engine, the power loom, like the very beginning of technology. You can see sort of in the graphic here, in the mid 1700s, mid to late 1700s is when Industry 1.0. But you can see the basis of technology here, right? The starting to put together tools and machines to increase human potential, right? And moving to in Industry 2.0 and the assembly line and sort of the beginning of electric power, and beginning of communications with the telegraph and telephone, are just adding to what humans can do. And if there's sort of a theme here, right, is all of these things are sort of growing this space around connection and around data. So moving on to Industry 3.0, you start to look at things. How do you organize and how do you um, modify and manipulate the data and the controls with things like the PLC, right? The beginning of the PC um, industry, right? And as well as robotics, right? How do you take in information, process information, and then manipulate things in real space? So with industrial robotics, right? The beginning of the internet, as well as how to design some of these things. So CAD. So Industry 3.0 was huge, right? 4.0 sort of takes that to another level with things like the Internet of Things, the birth of AI and machine learning, and growth of that space and how that's being applied to the rest of the ecosystem around computing, with cloud, right? AI and cloud are very adjacent when you look at how did AI blow up, right? You've got cloud and you've got this whole sort of data explosion in that same space, as well as things like 3D printing. Now you're able to build sort of on demand. So it's really about the information coming in, processed information going out, as well as actions going out. And so we're sort of in the middle of maybe middle to end of Industry 4.0. There are a lot of Industry 4.0 technologies that are still being, revised and upgraded and things of that nature. And then you have this future of Industry 5.0, and what does that mean? So you've got things where 5.0 is bringing together a lot of these different factors with cobots, collaborative robots now are working much closer with humans. It's not just control. Data comes in, the robot goes and does its thing. It's an interaction between humans and robots. So it's a very direct link to increasing human potential and being able to do things that previously you couldn't do. As well as quantum computing. There's been a lot of news about quantum computing. I think it's an amazing space, and we'll go on. When we're talking about Industry 6.0, I'm sure quantum will be a huge part of that, as well as sustainable manufacturing. There's lots of in Industry 5.0. There's the concept, and I'll talk about this a little bit later, of automating something or having sort of the next level of that, making it autonomous. All right. And so automating versus being autonomous. And there's a lot in Industry 5.0 that touches on that. So let's move on to the next slide. A couple of other definitions in automation. Um, Digital twin you guys are probably familiar with this, but digital twin relies on the data, right? If you didn't have the data and you didn't have the compute to simulate your whole real world as a virtual world, then you wouldn't be able to do it. So as you think about the progression of this, it really is this choreography between data and compute, and then the ability to now take that data and compute the analytics of it and then do something about it, do something with it. So digital twin is really a culmination of lots of data, lots of compute to be able to simulate and change the ecosystem. What happens if we go and do this in our virtual world? What happens if there's a huge failure? What happens if we don't have enough workers? So you can do those types of things with digital twin. Flexible manufacturing is very similar with respect to what happens if we need to reorganize this manufacturing line. How would you do something like that based on um, whatever circumstances you don't have enough parts for this. Well, we're going to switch to manufacturing these things and wait for, this other part to come in. We saw that quite frequently in during the pandemic where there weren't, certain chips weren't available or, the supply chain was broken in certain areas. Um, Operational technology, which is really key, and it's really sort of the underlying thing. We'll talk a little bit more about this, but it's the underlying nature of, you have the IT side, the information technology, and then you have the operational technology side. There's this sort of, we'll talk about the convergence of these, but operational technology is what's in the warehouse, what's in on the manufacturing floor, and so forth. Robotics technologies, there's a lot here. AMRs, which are the mobile robots that do material handling, bringing things back and forth. This area has really exploded in this space where, it used to be people having to handle materials or drive um, forklifts and bring materials from one place to another on the manufacturing floor. Well, now a lot of this can be automated and cuts back on injury. We'll talk about dull, dirty, and dangerous a little bit later, but it allows people to not have to be, risk. You can avoid risks and you can avoid challenges with the labor. Um, Collaborative robots, I talked about that. Vision systems and AI systems have been key in many areas, especially in robotics, where a robot needs to be able to understand its environment in order to adapt and navigate and be able to complete tasks or complete missions. Same thing with LiDAR and 3D cameras, which are components many times of these vision systems. Um, you think of a lot of people when they think of AI, in many cases, they think of generative AI. Like today is, when someone says generative or when someone says AI, they may think Chat GPT, which is generative AI, or LLMs. But there's a whole, of course, there's a whole set of other AI technologies like machine learning, reinforcement learning that, have been pretty prominent, especially in robotics, for quite some time. Um, and there's one concept, and I actually added this later because it's such a pervasive thing that we don't necessarily think about the aspects of safety when it comes to, first of all, data, safety, maybe privacy and security, but also in the robotic space and manufacturing, there's regulation around safety, and that's driving a lot of what's happening in the robotic space. As a matter of fact, if you look at humanoid robots today, a lot of what's driving humanoid robots is um, having a safer workplace, not having to expose people to dull, dirty, and dangerous situations, not having people have to, um, walk through the nuclear power plant that's, had some challenges, right? Being able to have robotics do that in sort of a field robotic space. But again, it really comes down to data, right? And it was funny. I think previous insights, um, Professor Vic talked about um, AI and talked about data and showed several graphs with these sort of hockey stick charts, right? And the hockey stick was really where data started to be able to take, there was enough data to where the charts started to take off and the models were able to really grow. And it's really about data. Uh, so Professor Parati was very key in talking about data with respect to AI. A lot of it is convergence of data. So let's move on here. So, the whole thing, this whole presentation really is about intelligent automation and how it applies. And there's several factors that really stand out with what's driving intelligent automation in the first place, right? And some of those those macro factors are, the workforce. That's one of the biggest things that you'll hear repeated about what's driving automation. Why are these robots here? Why are what's driving the AI. But workforce is a huge thing, and one of the biggest factors in workforce is this whole generation, the boomer generation, retiring, which is the biggest workforce right now. And really, when you think about that workforce, that's where much of the expertise in a lot of these businesses, whether it's manufacturing, whether it's supply chain, interlogistics, a lot of the expertise is in that population. And so when those folks retire, it's going to be a challenge if your workforce is not able to compensate for that. And so having AI, having expert systems, having robotics that can do some of that work, I think is key. So there's another piece of this, right? Is, you know, as this generation retires, healthcare is a sort of a primary focus, and we'll talk a little bit about that in a upcoming slide. Um, but also several other factors, right? The technology, the velocity of technology is increasing, and when it comes to how people are innovating, products that are coming up, software ecosystem that's growing, and what can be done with uh, these different these different items. It really shows that it's not a stagnant or static place, right? Startups are continuing to innovate. There are technologies or that are research that's coming out of colleges that's going into the ecosystem, leading the charge, so to say, or so to speak, with different types of innovation and technology that people are working on. Again, safety and regulatory, the juxtaposition of robotics and AI with people is driving safety, the safety regulations and safety um, requirements to have people, be safe around these robots. So there was a major safety regulation update that just came out at the mid of February. It's safety, if you want to look it up, it's safety standard 10 218 1 and 2, and it was just updated. I think it was 10 or 15 years ago or something like that. Was there the has sort of been the gap between when it was initially published and then updated. Don't quote me on that number, but it's been a significant amount of time since that was updated, and now it's been updated for this sort of new space of robotics. Uh, and then geopolitics, right? We all know sort of what's happening in the world, and where certain factions or certain people or economies and countries and economic blocks and so forth are positioned, and we all lived through the pandemic, and saw how that impacted the supply chain and subsequently industrial policy, and how that is impacting what's being built, where things are being built, what technology is moving where, and sort of reshoring of certain types of supply chains and so forth. So that's a big factor certainly when it comes to manufacturing. And there are lots of other local factors that, for me here in Atlanta's a big poultry processing state. And so there are lots of things where that have been in the news, right? Avian bird flu, right? That's a big impact here in Georgia. And so figuring out how to keep workers safe, it's a very manual job in some respects in processing food. And how do you keep people safe? So there's lots of things happening in that space that are driving automation. Again, we talked a little bit about health tech. Locally here in Atlanta, fintech, financial tech type companies are big. Age tech is a big growing industry, nascent industry here, and so you'll see a lot of things that are tied to these other factors, right? There's no single sort of silver bullet when you think about what something that's impacting the ecosystem is tied to some other thing. And if there's any takeaways from this presentation, there's two things that I would say is, and I'll talk a little bit about this more, but this evolution of converging inflection points. Um, take care to understand the data and how the data affects the rest of the ecosystem. I think that's a big thing, right? If we look at sort of the history of the industrial revolutions, it's been about really, to some extent, it's been about data. It's been about what data is available and how it impacts the rest of the ecosystem or rest of the factors. So there's many convergent inflection points. It impacts all of the things. It's sort of a matrix, and it's multidimensional, right? There's no one single factor that works by itself. And again, because there are many connections, and they're matrix connections, there are really few independent factors. So I would say, you know, treat them that way to drive really to drive ultimately the outcome. So think about it from a, if this changes, it's gonna impact something else, and then what is gonna be the output? And one big thing that I always talk about is culture, company culture. And so as a result of digital transformation, how has that impacted company culture? And just one simple big thing is return to work, right? The digital transformation, which has driven, all these productivity tools and things like Zoom and you know, uh, those things have really driven, change the culture, right? Like people now say, hey, well, I don't need to come into work to Zoom to somebody, overseas or whatever. I could do that from my own environment. So there's lots of impacts when it comes to, that are driving, or some of these factors driving intelligent automation. So again, many converging inflection points. One of the things that I wanted to point out was, the to illustrate this a little better is fastest growing occupations in the US, right? And so these are the top 10 um, uh, occupations. And you can see there's a mix of sort of health related stuff, data related stuff, and then output. So like, things that are physical in nature. So wind turbine service technicians, right? You're not, you may have robots that help with that process, but there's some physical aspect to that. So it may be robotic in nature or maybe person in nature, but there's also a danger associated with this. So that allows you to maybe start thinking if I were a startup, I would be thinking like, oh, well, this is a growing space. Maybe there's an opportunity for robotics, or maybe there's an opportunity for automation. Same thing with solar panel installers, right? Sometimes dangerous, could be potentially could be automated. So there are, in fact, companies that are building platforms or solutions in these spaces as well. But then, the rest of this list, you see data, you see health, and you see computer integration as well. So it's very interesting to see this sort of interplay between occupations and, where we stand with data and sort of bringing it all together. So I'll pause for a second. Jancy, are there any questions or any things that in the chat, or did I put everybody to sleep, or is there any engagement on your end?
No questions yet, but I was about to run a poll as you
Sure.
continue on.
Yeah, if you want to do a poll, that would be great. So very good. So, as we talk more about intelligent automation, where is this showing up? And I talked a little bit about this, but there's, manufacturing is a huge place, right? And especially here locally, I talked about, the supply chain and logistics, but automotive, electronics, consumer electronic products, home appliances, medical, all these places are where we're seeing in Georgia, in particular, where automation is being utilized. So there's you know, lots of focus in this space where whether it's on the scaling side, so businesses that are growing in this space, or on the startup side that are looking at how do they take automation and integrate it or build a business and build some outcomes around it. Of course, supply chain, the shipping ports have been in the news recently about discussing whether automation was good for the ports or bad for the ports, right? Or bad for the workforce, and how that interplays. So, again, this illustrates the connectedness of the solution side, the technology side, as well as the data side to labor and workforce. If you zoom out from the ports, the port issue, there's a lot of data around how automated ports work versus non-automated ports, as well as how much, um, how much business is driven through automated ports versus non-automated ports. So, there's always this discussion about jobs and how does automation impact jobs. In many cases, in many studies, you'll see that technology tends to drive and innovation tends to drive more jobs. There's a quote that I saw just recently is that 60% of occupations didn't exist 80 years ago, right? And although that's probably a pretty amazing fact to think about when you think about like 60% of jobs today, didn't exist 80 years ago. And you may think, oh yeah, great. There were no computers 80 years ago. So no programmers or, things of that nature. And so it sort of makes sense, but also, there's a way to plan for that, right? And if you don't plan for that, if leadership doesn't plan for that, then that's where I think the challenges most readily appears when there's no planning. There's no plan to, you know, exit this type of workforce and grow this type of workforce. And I think you've certainly seen the growth of computer programmers, right? Right. For as an RIT grad, right, there are lots of focus on computers and application of technology and so forth. Um, but that there's a way to sort of grow that or curate that transition versus sort of let things happen as they happen. So this was from a futurist on AI policy just recently, Sinead Bovell, a young futurist from Canada. So really good quote. I thought was very interesting. Another very interesting um, data point was that Universal Robots, which is a leader in collaborative robotics, sold their 100,000th cobot arm. I think it was just the other day, maybe earlier this week. But the president of the robotics division just mentioned that. And so the point of that being cobots, collaborative robot space is continuing to grow. Um, is is I think that's a sign that the technology is being adopted and automation is continuing to grow. So Industry 4.0 moving to Industry 5.0. One of the big, I think, driving factors of this is who's adopting the technology. And so, again, this list of different types of companies or different segments. Within that list, there's the big businesses, then there's the sort of small and medium businesses. And as that, as automation grows, there's certain companies that have the ability to adopt it, right? They have the budgets to, go and implement um, flexible manufacturing, and they have the types of products that they can seamlessly, build on the line. But not every company is set up that way, and a lot of companies, the smaller and medium businesses, are more set up to have a higher mix kind of product, right? Where it's not a low mix and just doing the same thing all the time, but a high mix where they may be changing things that they're doing. They may have several, different types of products that they make, and creating robotics and automation for that is more challenging, right? And it's also could be more cost intensive per implementation. So figuring out those things have been challenges. But Universal Robots, as they continue to grow this space with autonomous mobile robots, AMRs, continues to grow to sort of optimize this ability to not necessarily need the kind of automation that is low mix automation. So that's I think another sort of trending factor as well. Let's move on. All right. So one of the things I want to talk about is, we talked a little bit about IT OT. Um, I think this space and how this is coming together, this idea of IT OT convergence is really, I think, is an amazing example of automation, AI, all of these things coming together. And so when you think about IT has been around, early industry 3.0, OT as well, 3.0, 2.0, and how this is coming together and sort of what that means and what opportunities does it create. So you think about IT, you've got these sort of blocks here. You've got people, you've got systems, and you've got the interplay between them. So what happens in the sort of the interplay between these ecosystems? So IT, you've got your computers that people use on their desks. You've got servers in the back or servers in the cloud. You've got all the applications that run on, the antivirus, the backups, and all these things that you think about in the IT world. Same in the OT world. You've got these control systems, these robots, these um, uh, data librarians. You've got all this data that's being collected and that's going from machine to machine, sort of on the first order, right? So, virus and how many virus protection scans were run on your computer, first order data. Um, but you've got all these places where data is now coming together. So, when you think about what is data, what can you do with this data? Well, you run analytics and sort of understand what's going on in the ecosystem, and to ultimately do something about it. And so you've got analytics here, right? You've got analytics here, right? You get the point. There's analytics, there's data all over the place. But the interesting piece, and I think that's what's coming together, is now that you have all this data, what can you do with it? Well, you can connect this data to this data, right? You can connect this data to this data, and now you've got these sets of data that I can look at and use AI to understand, well, if this is happening here, now I can infer what's going on across these two nodes, right? Across these two domains. And so as you connect these different data points, you get the point, right? It's a bigger data set. Now I can understand, I can take more context out of what's happening across the whole playing field, across the whole landscape. So you have companies that are implementing AI using this data to now understand what's going on in their ecosystems. And some of that had been being done in AI in IT, but with this whole IT OT convergence, it sort of takes it to another level. And think about what are the second and third order impacts of that. What can you now infer based on all this data? And you start to think, oh, well, generative AI is a huge example of that. Um, and and how do you, sorry, let me just close this. How do you now go and sort of build outcomes based on all of this data, right? And so you can see you're using AI across this playing field. And what does that drive, right? There's all these impacts we talked about. It's all sort of connected, right? And so now you've got all this data. Well, what does that mean? Well, now you've got all these systems that are being used to calculate this data, right? AI is not free. There's calculations and so forth um, that are required in order to sort of pull all this stuff together. And so you're now driving the next level of hardware. So NVIDIA's Blackwell and all these next generation systems and Intel's um, uh, uh, systems as well, the Gaudi systems as well. So you've got all this hardware and all this technology that sort of builds on top of itself. And so at the end of the day, the AI grows and what can be done and what can be inferred from it across the business continues to grow. So um, let's see. And the thing to take out of this is really increased data in domains allows a deeper level of insight and a deeper level of optimization. So as companies look at, well, my competitor is using AI, how do I implement AI or what do I need to do to implement AI? Because now there's a competitive piece. If these guys are implementing AI to, better get to the customer, right? Better do digital transformation, there's this competitive nature that companies want to understand how do they take advantage of the technology and optimization. So there's this, sort of AI arms race that's been happening over the last few years, right? Which is driving you know, we've all likely have looked at generative AI, whether it's to help write a paper or help do some art or something of that nature. The key I think about is of AI is that it's a tool. And, you know, someone who's using the old version of the tool might not be as efficient. Using the new version of the tool is going to allow some efficiencies and innovation and optimal use of resources. And so that I think that's what's happening. And sort of tying this back to enhancing human potential, understanding the tool, understanding how to use the tool, where, when, to use the tool, when the tool doesn't work correctly, right? Obviously, if you can be a master woodcraft person, right, with the best tools, but if the the saw blade is not a good saw blade or is not the right saw blade for the wood that you're using, right? That's a challenge. And it's the same thing with AI, right? If you're applying the wrong data or biased data or, inaccurate data, then it's like using a bad tool. And so I think, as we grow and understand how does AI and robotics enhance human potential, um, it comes down to understanding how to use the tool when when it's working and when it's not. And we talked about sort of the first order information, second order, and third order insights. And just to kind of tie this back to an earlier slide, first order, we talked about data protection, um, making sure that hard drives don't walk away from the workplace, and security and things of that nature. Second order insights between IoT and OT, right? Predictive maintenance, optimizing different processes, things of that nature. SAP, like your ERP systems. Third order might be digital twin, right? Where you're taking a whole snapshot of what's going on in the workplace and now being able to, on demand, um, manipulate things within the ecosystem, do what ifs, right? That would be a third order. And then keeping humans informed in the loop real time. If something's failing real time or something needs to be decided real time, being able to provide insights from that digital twin or from some other AI system to help augment, you know, the user or manager of that system to figure out what to do next, right? And so, moving more from this automated system, right, to a more autonomous system. And autonomous could be autonomous with human in the loop. So, hey, the computers have done all the work. Here's the recommendation of what you should do now. What do you want to do? Human, you pick what you want to do. So, but with all the data supporting what needs to be done. So, um, again, pulling some of these pieces together, at the end of the day, what does this really mean? You know, I think what it'll drive is new business models, right? And we're seeing some of that, right? Early in this sort of um, data space, like big data, right? There was this idea of SaaS, so software as a service. As we integrate IT and OT, SaaS was a big thing on the IT side, but as well as OT, um, in infrastructure as a service has become a big thing, right? So being able to export the whole infrastructure, as well as robots as a service. So infrastructure could be, the whole network, the hardware, all these different things that are happening to be set up as a business model, as well as robotics as a service as a business model as well. So I think as you can start to converge all these things, it gives you other options of how to monetize this space, right? Different types of AI, different types of robots. I mentioned just a little bit later about this idea of um, generative AI in the big space. So we think about Chat GPT, we think about some of the big audio or some image, um, like Mid-Journey, image generators, some of those big things. But there are things where there's a specific domain of information that you want to stay within. So like a law specifically a law LLM, which may not be a large language model, but it may be a smaller language model that uses a law firm's particular, experience to now let that AI or that generative AI model suggest, things to look for or cases, case information to now go refer to. But it's a separate data set, right? It's not necessarily the whole internet data set and doesn't know everything about everything, but knows a lot about a specific topic. So you'll see, new types of AI, new types of robots that are focused on specific types of verticals or specific use cases. In particular, there's a lot of talk about humanoid robots is very popular right now, very popular subject. Um, and what would there's there's sort of a competition. There's the non humanoid robots, so like the AMRs and cobots and things of that nature as an automation tool. And then there's the camp that has this multifunctional, polyfunctional humanoid robot that is expected to really grow over the years. And if you look at innovation and investment, there's been a ton of money invested in the humanoid robots, right? Just recently, Aptronic got almost $500 million of investment. I think it was $350 million of investment to continue growing their space. Previous to that, Figure AI had, I think it was 600 and close to 650 million investment in humanoid robots, right? And so there's sort of a growing trend around humanoid robots, which is all based on, the AI backbone, right? The AI infrastructure that's allowing these robots to now do the things that they need to do has really grown, and that's all goes back again, comes back to the data. And many of these robots now are not just a control plane kind of activated robot where you have, some program that says, move this arm here, move these joints this particular way. A lot of them are taking advantage of, reinforcement learning and simulation to use those inputs to now drive what the outputs are. Things like what Google DeepMind have done in their space around robots like this playing soccer. A lot of that is using AI models to now train the robots to do the particular things. Like they should have these particular types of stances when they're doing this particular chasing the ball or so there's a direct link between data, AI, and robotics, and then ultimately the idea is again to many for like Aptronic and Figure AI, they're focused on using humanoid robots um, to fill in from the lack of labor in certain areas, especially in manufacturing. Both of them are focused on manufacturing. And so, you can see sort of where this is going. And again, when you think about data and you think about AI, it's really incumbent on humans. It's a sort of a feedback loop, right? It's the technology is going to do something for the humans, but the humans also change because of the technology. And I think it's critical to be aware of because it's not always in the equation. Like companies think that the technology and the process sort of supersede everything, but really it's the culture that Drucker said culture eats strategy for breakfast, right? And so if you think about how people react to the technology, it's really incumbent on people to help drive that and be aware of those things and the nature of technology. So um, I sort of jumped ahead or jumped around a little bit, but again, if you think about where does this culminate? Where does this, sort of where we are today? There's new data and privacy paradigms, right? Like where's the data coming from, right? Again, we talked about LLMs and sort of the exposure to the full network, exposure to Reddit and conversations in those types of things. And how that influences the data, like what's in the model, how does that influence the data? How does the data influence the output of the model? So being critically aware of those things. We talked about large language models and small language models. And I also talked a little bit about the Industry 4.0 moving to Industry 5.0, and automation moving towards this idea of autonomy versus, just having a process or some, supply line or supply chain, value chain portion automated, right? Um, there's this idea around fault tolerance of the system, right? And so if you have a factory, there's a push in maybe industry 5.0 industries, beyond that, to where you can operate a factory lights out, right? You don't need humans, you don't need lights, you don't, the robots can kind of go do everything. And that really that ties back to, that's likely an industry 6.0 thing. I think people are thinking about those, but there's no real, I don't think there's any real good examples of that technology being implemented. But the idea of AI being an expert, right? As as we talked about, the boomer generation retiring, a lot of that expertise is going to go away. How do you capture that? Well, AI is a good place to capture that. And you know, there's in several manufacturing industries and industries of that nature, not everyone is an expert, right? Not everyone is an expert on a particular tool or a particular process. It takes time to become an expert. And so as these experts retire, being able to capture that in AI is attractive in many ways. So and then be able to use the AI to now train new people to be experts. And so there you'll see that as well with how, specifically how AI and robotics enhance human potential in a direct way, right? Um, I always talk about culture shifts because it's something that I don't think is always covered. It's not always talked about when um, I think more often it has been this. It feels like this year there's been sort of this awakening of how digital transformation is impacting people and how people are now impacting the ecosystem that digital transformation is happening within. But the culture shifts, I think, ultimately companies want to see dull, dirty, and dangerous um, situations, jobs, things of that nature be automated, right? You don't want people to get, having health issues and things of that nature, or not being replaced from the workforce because they want to avoid those things. But robotics being used in that space, right? In terms of quality of life, better jobs and better products out of this idea of automation. But again, many, again, if anyone takes anything away from this presentation, it's about this idea of these converging inflection points, and the idea that people will need to stay engaged, right? It's not going to be, Wally, where, all the people are riding around on their hover chairs and things, and all the robots are doing everything. People need to sort of stay engaged in this space. And so I think I was going to leave 5 minutes for questions. Jancy, do you want to do another poll?
So we do have some good questions in the chat.
Awesome.
One of them was actually a nice tee up from your classmate, Tony. He had mentioned that a Wall Street Journal article reported that the drug industry in China is utilizing AI to speed up drug discovery and clinical trials, and the results are on par with what is being put out in the US. And I think that actually connects to another attendee's question of if there's any current government regulation on AI or robotics in the US labor market right now.
Yeah, I think there's some, but I think it's an evolving space, right? I think the US is behind when it comes to regulation. From a regulatory perspective around AI, there are a lot of camps, right? It's funny, Vic shared a slide set around the several folks from Google who sort of broke off and created their own focus on AI. Timnit Gebru was one of the leading researchers there, on what AI is not doing and right the challenges with AI. And so, I think that rolls really right into the question of regulatory, from an AI perspective, regulatory and how that's being handled from a government perspective. It's evolving. If you talk to um, companies in this space, they will admit that, hey, we don't have all of the T's crossed and the I's dotted, and I think that will continue to um, evolve. I think in Europe they're, I think, a little more advanced from a regulatory perspective. Some of that's changing, and it does come down to what leadership in these spaces are doing, what leadership in some of these government and regulatory bodies are, how they're positioning. Some are like, let do everything, right? We want to innovate and continue to innovate. Any kind of restrictions stop innovation. And so a lot of it is, again, comes back to my big key takeaway, right? Is lots of converging inflection points that people need to be shaping, and that regulatory, I think, is a key one. Safety is a key item that people need to be focused on, and if it's in your domain, you need to be aware of what is happening and help drive that to the right conclusions. So don't it's not Jesus take the wheel at this point. It needs to be us kind of figuring, I mean, some of that as well, but depending on your perspective, but it also needs to be people looking at how is this impacting other people. So hopefully that answers some of the question.
Definitely. And then just one final question that was just slid in here was, which ROI parameters would you use when offering AMRs to industrial material handling applications?
It's a great question. There's, depending on, when you go into a factory and you look at how is this factory operating, right? What are we trying to do? What are the KPIs? It really comes down to industry KPIs. How fast is the AMR? Does the AMR have manipulation capability? Is it a mobile manipulator? What's the load capacity, right? Is it a forklift or is it just sort of a flatbed? I mean, there are lots of things to do when sort of go do your initial discovery in deploying an AMR. And what's so crazy is that there's so many AMRs. There's so many AMR companies that are building these platforms that you have a lot of choice to vet at this point. Like you know a couple of things that might be of interest are how does the operation work? And if you think of like sort of like an Amazon, right? Amazon deployed a bunch of AGVs, right? That's where all the main brunt of their robotics are AGVs, and it's almost just a little under 1 million robots that they've deployed. Well, AGVs have to be safety cordoned off, right? They're all in their own space. And how does that impact efficiency in the warehouse where you have, other robotics companies that are more collaborative AMRs where that are, their AMRs are autonomous. They have vision, they have systems, they have safety systems to where, if somebody runs out in front of them, they can stop. And so how does that, like a Locus robotics platform, how does that now change the paradigm with in the factory? There's no silver bullet figuring out what kind of system you want to deploy, whether it's AMR, AGV, ASRS system, which is basically the sort of corollary of a random access memory, like a hard drive, right? You can just sort of store things in this cube of automated robotics, right? Something like Exotech. Um, so, I don't think there's a silver bullet. I think you have to walk through what's the use case, what are the KPIs, and then what's needed. In some cases, you have palletizing robots that drive a huge ROI in the workplace, right? And then you have a bunch of humans that sort of drive forklifts and deliver and load platforms. But you have someone like Slip Robotics, where they have a robot that's basically a pallet, right? You put everything on the robot, and the robot drives into the truck. You deliver the truck, and then the robot drives off of the truck, and now you depalletize. And so it really comes down to the business. And I know I've talked too much, so
You've
hopefully
given,
that answers the question.
you filled our brains with knowledge today.
Yeah.
Is what we need and what we do what we do at a place of education. But thank you so much for sharing all of your insights. And I'm going to pop my slide up in a moment when it works for me. And this is less than a minute for anyone that is still on right now. But just some friendly reminders after today. This recording will be available the end of this week, so you can relive all the knowledge if you want to revisit one of the moments today. For anybody who is a prospective candidate looking for their next challenge, and if 2025 is your year for an executive MBA, if you apply for ours by March 15th, you can qualify for a $2,500 early decision award, as well as some additional scholarship. And as Noah had mentioned earlier, we are accepting capstones. So if your business has a problem that you're looking for some external insight on, and you're willing to take the time and you want to save some money, partner with our executive MBA students and submit a capstone by April 1st to be considered for this academic year. Again, Milt, amazing presentation, and thank you everybody for attending today, and hopefully you join us for the next one in March. Take care.
Thank you.